hermetic refrigerant motor compressor is a sealed unit. The motor and compressor are enclosed in a single housing. The outside condenser of a heating, ventilation, and air conditioning unit typically contains a condenser coil, fan motor, and other components. These components are not enclosed in a hermetically sealed unit. According to the National Electrical Code, a number 10 wire cannot be used on a 40 amp breaker. The maximum breaker size for a number 10 wire is 30 amps. This is referenced in NEC Article 210.19. A2, which addresses branch circuit conductor sizing. It states that branch circuit conductors shall have an ampacity not less than the maximum amount of the non-continuous load plus 125% of the continuous load. Understanding ampacity is crucial. Ampacity is the current, in amps, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The National Electrical Code provides tables that list the ampacities of different wire sizes and insulation types. These tables take into account factors such as the ambient temperature, the number of conductors in a raceway or cable, and the type of insulation. For example, NEC Table 310.15 B16, which was formerly Table 310.16, provides ampacities for insulated conductors rated up to 600 volts, not more than 3 current-carrying conductors in a raceway or cable or earth directly buried, based on ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit. The table lists different ampacities for different wire sizes and insulation types, such as copper and aluminum conductors with insulation types like THHN, THW, and others. The NEC specifies different ampacities for different wire gauges to ensure safety and prevent overheating, which could lead to insulation damage or fire hazards. The ampacity of a conductor is influenced by its size, material, and insulation type. Larger conductors have a greater cross-sectional area, allowing them to carry more current without overheating. Copper conductors generally have a higher ampacity, and aluminum conductors of the same size. Different insulation types have different temperature ratings, which affect the ampacity of the conductor. For instance, a number 10 copper wire with THHN insulation, which has a higher temperature rating, will have a higher ampacity than a number 10 copper wire with TW insulation, which has a lower temperature rating. When selecting a wire size for a particular application, it is essential to consider the load it will carry, the ambient temperature, the number of conductors in a raceway or cable, and the type of insulation. The wire must be sized so that its ampacity is sufficient to carry the load without exceeding its temperature rating. It is also essential to comply with all applicable requirements of the National Electrical Code. Circuit breakers are designed to protect electrical circuits from overcurrents, which can be caused by short circuits, ground faults, or overloads. When an overcurrent occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to the wiring and equipment. Circuit breakers are rated in amps, which indicates the amount of current they can carry before tripping. When selecting a circuit breaker for a particular circuit, it is essential to choose a breaker that is properly sized for the load. The circuit breaker should have an amp rating that is equal to or greater than the ampacity of the conductors in the circuit, but not greater than the ampacity of the equipment connected to the circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overheating and potential fire hazards. The National Electrical Code specifies the maximum overcurrent protection for different wire sizes to ensure that the conductors are adequately protected. NEC Section 240.4 D provides specific rules for protecting conductors, stating that overcurrent protection shall not exceed the ampacity of the conductors being protected, unless specifically permitted or required in 240.4 E or 240.4 G. These exceptions address specific situations such as tap conductors, fixture wires and cords, motor circuits, and air conditioning and refrigeration equipment. For example, NEC Section 430 covers the requirements for motor circuits, including the sizing of conductors and overcurrent protection devices. The code specifies that the conductors supplying a motor must have an ampacity of not less than 125% of the motor's full load current rating. The overcurrent protection device must be sized to protect the conductors and the motor from overloads and short circuits. Similarly, NEC Section 440 addresses air conditioning and refrigeration equipment. It provides specific rules for sizing conductors and overcurrent protection devices for equipment that contains hermetic refrigerant motor compressors. These rules take into account the unique characteristics of these types of equipment, such as the inrush current that occurs when the motor starts. The National Electrical Code provides detailed guidelines for selecting the appropriate wire size and overcurrent protection for various electrical applications. These guidelines are based on extensive testing and research and are designed to ensure the safety and reliability of electrical systems. Consulting the NEC and other relevant standards is crucial when designing and installing electrical systems. For example, for a 40 amp breaker, you generally need a larger wire gauge than number 10. Typically, number 8 copper wire or number 6 aluminum wire would be appropriate, depending on the specific installation conditions and temperature ratings. Always consult the NEC or a qualified electrician to ensure compliance with local electrical codes. The NEC provides tables and guidelines for determining the appropriate wire size for a given breaker size and load. These tables take into account factors such as the ambient temperature, the number of conductors in a raceway, and the type of insulation used in the wire. Using the wrong size wire for a given breaker can create a fire hazard. If the wire is too small, it can overheat and melt the insulation, leading to a short circuit or fire. It is important to always follow the NEC guidelines and consult with a qualified electrician to ensure that the wiring is safe and compliant with local codes. The National Electrical Code is updated every 3 years to reflect changes in technology and industry best practices. Staying up to date on the latest edition of the NEC is essential for anyone who works with electrical systems. In summary, selecting the correct wire size and overcurrent protection for electrical circuits is crucial for safety and compliance with the National Electrical Code. Understanding ampacity, temperature ratings, and the specific requirements for different types of equipment is essential for ensuring the safe and reliable operation of electrical systems. Always consult the NEC and a qualified electrician when designing and installing electrical systems. Firstly, conductors must be sized appropriately for the load they will carry, taking into account ampacity, temperature ratings, and other factors. Secondly, overcurrent protection devices, such as circuit breakers and fuses, must be sized to protect the conductors from overheating and potential fire hazards. Thirdly, the National Electrical Code provides detailed guidelines for selecting the appropriate wire size and overcurrent protection for various electrical applications, and it is essential to consult the NEC and a qualified electrician when designing and installing electrical systems.